All right, question number 11 is an interesting question because if we look at the graph and then look at the answer choices we have, we see that we're actually going to be working with two types of graphs in this scenario, or we at least need the background knowledge of two different graphs. The dot plot shows the average daily temperature in degrees Fahrenheit for various days. And so we can see that, right? Temperature along the bottom, 60 degrees, 61, 62, 63, and so on. And our dots represent, the various days that were that temperature. Which statement about the data is true? We want true. And this is where we know we need to have information pulled out of our brain and applied here about box and whisker plots because we're seeing interquartile range, which again, right, is talking about the range of the box. And then, of course, the overall range. So what I would suggest to do first, because our range is either listed as 65 or 5, let's work on finding just the plain Jane range and then eliminate some basic answer choices off of that. We don't have to work as hard to do that. So at the very least, if you're super stuck, you could use this and at least give yourself a 50% chance of getting it correct if you just completely kind of space out on the second part. So we have to figure out what is the highest daily temperature. What was the warmest that it was? Now, I had someone last year answer a similar question to this, and they said that the highest temperature was 4 degrees. What do you guys think? I mean, there are 4 days where it was 63 degrees. Our highest temperature was 65. Our lowest temperature was 60. We can see that here. So our range, again, right, high minus the low, so we've got 65 minus 60, which is 5. So how awesome is that? That means that we can get rid of 2 answer choices. So now we're down to just 2 of them. And you know what I might do even? I just block it out completely. Oh man, I love this page marker tool. If you guys can, if you have an AISD Chromebook, you can add it there too. Get the page marker Chrome extension. All you have to do is Google it. Page marker. Whoopsies, marker. Chrome extension. Google it, install it. It looks like this little red marker right there. It's amazing, and that's how I write on everything on the screen. It's super helpful, especially with all of these graphs. Okay, now the second thing we're going to see is that I gave you a hint to list out all of the data so that we can actually find our interquartile range. Remember, that's the box. And remember, our box is made up of our medians. So that's going to be really important that we list out everything so that we're able to actually mark on our data and see what's going on. So here we go. We've got 260, so 60. And I probably should make this a little thinner so it fits in here nicely. You can actually see it. So 60, 60. Oof, my goodness, guys, I don't think I'm giving myself enough room. This is why, if you're doing this at home, hello, paper and pencil. 60, 60, because there's 2 dots. So I'm going to mark those off. 361, 61, 61, 61. Mark those off. 362, 62, 62, 62. 4 63s. 1, 2, whoopsies. 3, 4. 64, 64, and our last one, 65. All right, now we always double check it. You guys, in one of the classes, I had 4 things to count, and I counted to 3, so no one's immune to goofs. We've got 2 60s, good. We've got 3 61s, 3 61s. We've got 3 62s, we needed 3 62s. We've got 4 63s, that's good. We've got 2 64s and 1 65. Okay, so remember, I'll even draw a little box up here. right? Because remember, our whiskers are made up of our minimum and our max. But our box is created from our medians. We've got our low median and our upper median, our higher median. So the first thing we're going to do is just kind of solve for that. I'm going to mark above it so that I don't have to delete everything. So we've got how many data points? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. That's really nice because that means we're only going to have one number in the middle and we need 7 on each side, right? 7 plus 7 is 14 plus the 1 in the middle will give us 15. So that means we need 7 on each side. So 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. So that should put 62 in the middle. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Okay, so now what we have is our lower data, and then we have our upper data, right? And we know that our median, our upper median, and our lower median are the high and the low of our box and whisker plot. So we need to find that median for the lower data, and we need to find that median for the upper data. Okay, so we've got 1, 2, 3. So I'm going to mark off 1, 2, 3. 1, 2, 3. All right, so I got 61. And 1, 2, 3. 1, 2, 3. And I got 63 up top. Okay, so again, what we did is found our median of our data, and that divided our data into our lower data and our upper data, which is super important because our box, our interquartile, if we want to find the range of it, that means we need to have the lower median and the upper median, and that's exactly what we found here with 61 and 63. All right, guys, we need a difference of that. How far apart are 61 and 63? They're 2 apart. So that means this little nugget is incorrect. And our final answer for this one should be the interquartile range is 2, and the range of the whole thing is 5. A lot of work. This one took probably everything we've learned this 6 weeks to solve this one complex problem. So if this was tough, that's okay. You came back to this resource to utilize as a help tool, and that is crucial and the most important part, and I'm proud that you did that today. All right, let's move on to question 12. All right, Marcus gathered information on the heights of all students in his class. He put his data on a histogram. It looks like a bar graph, but remember, it's a little different. Which of the following statements is true about the histogram? Ooh, that's important. We need something that is true. Okay, so let's take a peek. Heights. So we have 48 to 51. That's 2 people. Before we do anything, you guys, organize your graph a little. Right, 10 people that fit here. It looks like a weird 10. 6 people that fit here, and 3 people that fit there. Okay. Now remember, what's interesting about histograms is that we sometimes cannot pull specific data. For example, this 64-inch to 67-inch range, how many people were 65 inches tall or 66 inches tall? We don't know specifics, right? Everyone in that group, for all we know, could be 64 inches tall. We don't know. We just know they fit into that height range. Let's see, there are twice as many students who are 48 to 55 than there are 56 to 69. Well, let's do that. 58 to 55, well, that's 2 groups, so that would be 5 people. 56 to 69, here's 56. Ooh, to 69. Maybe that's a typo. Maybe that should be 67. I'm going to fix that later. Let's say that's 67. That would be everybody else, which would be 19 people. And you guys, there are twice as many of this group as all of these. That's totally bogus, totally false. Let's see the next one. There are more students who are 64 to 67 inches tall. Let me grab a new color for this one. More students, okay, that is 3 people, than students 52 to 55. Well, they're equal, so that's false. I want you guys to notice that the work I'm doing to prove or disprove these answer choices, it's not much, right? But I am showing my thinking by putting those numbers above the information in the question. There are half as many students, 52 to 55, that's 3 people, as there are 60 to 63. Well, are there half as many in this group as they are in this group? Yes, because 3 is half of 6. So that looks good. But let's take a peek at the last one. It's going to jumble up everything, but we'll take a peek. There are 2 students in the class with the height greater than 67 inches. Well, maybe, but not according to this graph. We can't prove that. So that would not be a true one based off of this graph. It's going to be C on this question. All right, let's move on. Question number 13. Ryan made a stem and leaf plot to keep track of the points scored by his basketball team in several grades. Which statement is best supported by the data? The team scored between 70 and 79 in more games than they scored between 80 and 89. Okay, the team scored 4 points in 3 of their games. The team scored 80 and 89 between 80, ooh, that's important, between 80 and 89 in a third of their games. The team scored 75 points in more games and they scored 83 points. So you guys know me. We're going to work efficiently. So these two seem the quickest to prove or disprove. So let's start with those. Oops, sorry guys, I almost fell. I'm sitting on an exercise ball with my chair and I almost fell off. The team scored 4 points in 3 of their games. Let's remember how we read a stem and leaf plot. We've got our 10s and our 1s. So this would read like 66. This would read as 69, 73, and so on. Did they ever score 4 points? Not according to this. It looks like their lowest score was 66. So I would say that one is totally bogus, and it did not take much for us to disprove it. The team scored 75 points in more games than they scored 83 points. That's going to be a quick one. 75 points. That's 2 games. And 83 points would be also 2 games. So that is not true because they are equal. False. False, 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 false. Okay. Now let's erase this so we can look at the next one. Grab a purple color, trying to do different colors for each of these. The team scored between 70 and 89 in more games. Okay, so let's do that one. That one looks like we can highlight some things and it might go a little quicker. 70 and 79. So that's all of these. Then they scored between 80 and 89, which would be these. Well, did they score more in the 70s than they did in the 80s? False. They scored they scored less, right? In the 70s, they scored 1, 2, 3, 4, 5, 6. And in the 80s, they scored 7. So that would be false. So process of elimination, we know it's going to be C, but we could have goofed on some of the others, so we need to be able to prove it. Always, always, always. The team scored between 80 and 89 points in a third of their games. Okay, we see a fraction. Did anyone's brain just freeze up because you saw a fraction? Don't freak out. It's just a fraction. First, let's figure out how many games did they even play. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. All right, you guys. They scored 21 games. We're talking about a third of them. So a third, that means we're chopping something up into 3 parts. What's 21 split up into 3 parts? 7. So we're looking for them to have scored 7 games between 80 and 89 points. And I think we already talked about that one and figured out that that's true. That'd be here. Hello. Whoops. I didn't mean to mark through it. I meant to highlight it. I meant to do this. Is this 7 games? 1, 2, 3, 4, 5, 6, 7. Yeah, they scored 7 games between 80 and 89 points. And 7 is 1/3 of all of them there. So that is our correct answer. We answered some, we already eliminated some fairly quickly and then had to do a little bit more work for some, which is pretty nice. All right, last couple. Mr. Peterson displayed the test scores on the dot plot below. Which statement is best supported? Ooh, true. Best supported by the data. Ooh, we have a hint. List out all the data from the graph. All right, because we have a dot plot, but our answer choices are median and interquartile range. So I think I'm going to start this one off by listing out all of the data. So we've got 1, 2, 3, 4, 5 people. It said 60. Yes, we have a little bit of work to do, but you guys, a little elbow grease. We can do this. What did we say? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. All right, 70's got 4. So 1, 2, 3, 4. What is this? 75, 76, 77, 78 has 2 people. 78, 78. 80 has 3. 82 has 1. 2 people scored a 90. 3 people scored a 95. And 1, 2, 3, 4, 5 people scored a 100. Wow. List everything out. 1, 2, 3, 4, 5. All right. Again, we just double check. We've got 5. We've got 1, 2, 3, 4, 5 60s. 1, 2, 3, 4, 5 60s. 1, 2, 3, 4 70s. 4 70s. 2 78s. 2 78s. 2 8. Oh, SpaghettiOs. I only listed out 2 of them. That's why we double check. Hello. Good thing we double checked. We've got 3 80s, you guys. 80, 80, 82. There we go. All right, 3 80s, 3 80s, 182, 182, 2 90s, 3 95s, and 1, 2, 3, 4, 5 hundreds. 1, 2, 3, 4, 5. Okay. Was it worth it to double check? Hello, yes, because I goofed. No one's immune to those. All right, let's work with the easier one first, but I'm going to remind you guys, right? When we're working with our box and whisker plot, remember our tails, our whisker, oopsies, hello. Let's get the correct words here. The whiskers are our minimum and our maximum of our whole data. And then our box is made up of our median, our line in the middle, and then we have our lower median, and then our upper median. Okay, so we're going to find the median of our whole data first. And I'm just going to do a quick count. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. Okay, we have 25 data points. So that means we are going to end up with one number in the middle because that's an odd number, odd one out. We're going to have 12 on each side. 12 plus 12 is 24 plus our one in the middle. So 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. All right, I'm going to mark it right here. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. All right. There's my upper data. So we got 80 in the middle. So that means we can get rid of our two answer choices. How awesome is that? And we might just completely block them out. They're out. We don't need them. Now we're down to 2. And remember, right, we have our lower data, and then we have our upper data. And those are going to create our range, because remember, our interquartile range is our low and the high of the box. So we need our low median and we need our upper median. Okay, so we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So that means we've got whoops, that's really big. I want to still see my numbers. 1, 2, 3, 1, 2, 3, 1, 2, 1, 2. We've got 2 numbers in the middle, so that means we need what's in the middle of that, which on this one is just going to be 70. Same thing over here. 1, 2, 3, 1, 2, 3, 1, 2, 1, 2. 2 numbers in the middle. They're the same number, so it would just be 95. So that means our interquartile range goes from 70 to 95. So interquartile range, the range of the box, high of the box minus the low of the box, would be 25. So our answer for this one is B. Lots of things going on, but again, we really just focus on 2 essential things. Finding the overall median, and then finding medians of our lower and upper data. It may look overly complicated, but all we did, again, was find the middle number of our data, and then we found the middle number of our low data, and then we found the median, the middle number of our upper data, and use that to sort out what we were working on. Awesome. Let's take a peek at question 15. Question number 15. All right, let's see if we can get that to go away. There we go. All right. Hector surveyed all the 6th graders at his school about their favorite after-school activities. The results are shown below the table on the right. Which percent bar graph best represents the data? All right, so I'm going to scooch this so we can see a little bit more. Okay, so right off the bat, we always want to take a peek and see, are there any that we can get rid of just based off of reasonableness? And there are, right? If we look at answer choice A, all of them have 25%, right? 50 to 75%, that's 25, oops, it's a weird 25%, 25%. That means they all would have the same number of students voting for that activity, which is false. Some of them are more and some of them are less. And let's take a peek at B. This is saying that reading, sports, and video games were really small compared to music. Were they really small compared to music? Not really. I mean, they were all fairly close to each other, so they're all going to be kind of similar. We might have some that look, of course, lower, but not that low, right? That's really, really small in comparison. And saying music, that's saying that like most of the people chose music, which is not true. So now we're really down to these last couple. And you guys know I'm all about working smarter, not harder. So let's take a peek and see what percentages we have for each of these. So we have 20% for reading. This one has 15%. 20, so that's 10, 25, so that's 25%. 10, 20, again, 25%. And then this one, 10, 20, 30%. Okay. Then we've got, let's see, 5, 15, 20, and then a little extra, so it's not exactly. So 25, maybe like 20, I don't know, do you want to say that's like 2? Maybe that's 2, so 27%. Okay, and then here we've got 10, 20, and then, yeah, maybe it's like 27% too. I bet that's supposed to be maybe like 28% or something like that. So I'm just going to do this. Like, it's about that much. 10, 20, 30, since it's not super exact. So quick check. We can see that they both have the same amount of music. Sports and video games are the same percentages, even for these that are a little weird. They're pretty much the same. And so we can't eliminate it based on that. The one that seems the most promising to choose is going to be to work out the percentage for reading. That way we only have to do one part of it, right? So let's see. Whoa, you guys, whoa. All right, so let's do that. So reading out of total, okay, because we know that percents are out of 100. Percents are out of 100. So let's look at what we have. We have 44 that chose reading, and what we need to do now is figure out, well, how many people did he ask? It would be nice if they told us in the story, but we'll take a second and we'll add them up. I would probably start with 44 plus 66, right? That's going to give us, 110. And then, of course, 55 plus 55 is also going to give us 110. We can do that. 110 plus 110 gives us 220. Gives us 220. So what we're going to do from here is focus in on how do we get from 220 to 100, right? That's going to be the tricky part for us, because I bet we're looking at this and thinking, uh-oh, it doesn't really go so easily from one to the other. So we're not going to stress. We're going to remind ourselves it's not a big deal, because we know that ratios, what we just did, what we just worked with, it's really just working with fractions. So let's see. What can we divide 44 and 220 by? They're both even, so we can divide them both by 2, right? Cut 44 in half, and we get 22. Cut 220 in half, and we get 110. We're still not quite there yet, are we? So let's see if there's anything else we can do. We can do a little bit of, let's do a little bit of investigative work. Let's do a little bit of reasonableness, because we might not get there on an easier route. Like, let's think about this with, again, the less work we can do leaning on just our estimation and reasonableness, the better. Because 22 out of 110, that is pretty close to 100. That is like ridiculously close to 100. And remember, our possible answers are 20% for reading and 15% for reading. Okay. Which of these do we think is most reasonable? I mean, you guys, it's really close. I would say 20% is totally okay. And then if we want to do a quick check for the others, we could. Now, another thing that we could also do to apply this and not have to think as much is, let's see if I don't destroy everything. We're going to take a peek at a couple of things. Okay. All right, so earlier we said, right, sports and video games have the same percentage, but they equal 110. And we know that the total is 220, all right? You guys, what's half of 220? 110. So our sports and our video games should be 50%. Absolutely equal to 50%. They can't be anything else. And so if we take a peek, right, we already said that our 20% was pretty close. Our sports and video games were exactly 25%. Oopsies, not 220. We're exactly 25% in our answer choice C. So I wanted to point out the first section because I know that in the past, kiddos have chosen to tackle this by looking first at reading and seeing if they could eliminate an answer choice that way, and then got really stumped once they got here. So we can lean on estimation and reasonableness on this first section, and then I really wanted to bring back the fact that sports and video games really made up a half of the people, exactly half of the people. So that had to be exactly 50%, which is what we saw in C.